Calculate the pH of 0.62 molarity of the hypothetical dibasic acid with a chemical composition of H2A, with Ka1 being equal to 5 times 10 to the power of -8 and Ka2 equal to 8 times 10 to the power of -7. So step 1 is calculate how much H is produced from the first reaction, which is H2A, to HA plus H. Now we know the initial is 0.62, 0, 0. We know H2A will decrease by -x, HA will increase by x, and H also by x. We know the final values will be 0.62 minus x, HA will be x, and H will be x for the final value. Now, using Ka1 is equal to the equation, we are able to figure out that x can either be 0.000176043 or the negative value of it. Now, we cannot have negative solubility, so it's just a positive value. Part 2 is to calculate how much H is produced from the second reaction, which is HA to H plus A. Now we know HA will start off with X from, well, the first part. We know A will be 0, but H will also be X because that's how much we figured out from the last one. We know that HA will decrease while A and H will increase by Y. Now the final values will be X minus Y, Y, and X plus Y. Plugging in those values, like we did in the first one, we get 7.92827 times 10 to the power of -7 for the value of Y. The last step is to calculate the pH, which is just log of 10 negative of H, which is from the table is just X plus Y. So negative log of 10 of the two values will ultimately give us 3.7543.